Hi guys, good morning. So in the last session, we have seen about ether channel concept. Today, let's see about VLAN access list. Now, what is VLAN access list? So VLAN access list is used to filter the traffic within a particular VLAN. So within a particular VLAN, maybe you don't want a particular node to communicate. So in that case, we can use VLAN access list. So how you can define it? You can say VLAN access list or VACL is a tool that is used for like access list used for filtering, right? So used for filtering the traffic within a particular VLAN. Within a particular VLAN, you want to filter the traffic. Now, how do you apply this VLAN access list? Okay. So number one, you say create the access list. Create the access list. Now, how do you create the access list in a router? What is the command? Access hyphen list. Then you give a number. Then what else? You will give either permit. Then if it is extended, then what you will give? Protocol, source, destination. That's it. So see here how you will write. You'll say access hyphen list. Then you'll give a number. So I'll say here, this is the ACL number. Then you'll give either permit or deny. But here, always it will be permit. Why? Because your access list here in the access list rule, we are not taking a action. This will work as a selector only. That means we are just selecting the traffic, that which traffic you don't want to allow. So you'll say permit, then all the IP protocols or a specific protocol from the host, then you'll give the source IP, then you will give say host and you will give a destination IP. Here, once you have done this, then what we need to do, we need to create an access map. We need to create an access map. So in the access map, what we will do, we will configure the action that you want to allow or deny the traffic. So you will say create VLAN access map, okay, to block or permit the traffic, to block or allow the traffic. This is we need to do. So how you will do it? You'll say VLAN access map. Then we'll give a name to this access map, and we'll give a sequence number. Same like route map, how you created the routing, if you have used, right? Then you'll say match IP address, and you'll give an ACL number. Okay, and then you will define an action. That what is the action you want to take? Either you want to drop the traffic or you want to forward the traffic. Once this is done, then to allow rest of the traffic, let's say this is the traffic I want to drop. To allow rest of the traffic, again you will create the same thing. Same. Exactly same. But this time inside we will not give anything. That means by default everything is permitted. Then what we'll do, we will attach this VLAN access map. Okay, so to attach this VLAN access map, what you'll do, you'll say attach the VLAN access map to VLAN filter. And you will say VLAN filter, then we'll give the access map name. Then you will say VLAN list. Okay, and in which VLAN you want to filter the traffic. So here we give the VLAN ID. These are the three steps to configure a VLAN access list. So first thing you will do, you are going to create the access list to select the traffic that from where to where you want to block the communication in a VLAN. Then you will create a VLAN access map to define the action. And once you have defined the action, now you will decide that, okay, in which VLAN. So to define the VLAN, we will just use a VLAN filter. This is clear, right? Now let's see this thing practically. Note it. Note it down. Done. Okay. So now switching. VACL. So I'll use a switch. And let's say I'll use three PCs. Or let's just use two PCs only. That is also okay. By default, they will have communication. Then we using ACL, we will block and check, right? PC1, PC2. Start all nodes. So here I'll give the IP address 10.1.1.1. And here 10.1.1.2. This is the switch where we'll be doing the configuration for VACL. And then I have PC1. This is PC1. This is PC2. Okay. So now let's configure IP addresses. I'll use default mask only. Okay. Let's verify the IP address. 10.1.1. 112. Okay. Let's test the communication right now. Ping 10.1.1.2. You see, I have communication, consistent communication I'm having. Let me do one thing. I'll just start regular ping so that regularly it will start pinging. This is clear. Now what we'll do, we will configure VLAN access list and we will see as soon as the access list will come in action, this communication will stop. Okay. So let's go here on the switch. And now let's create. So first of all, I'll go to the global configuration mode and let's create the access list. I'll say access list 100. Okay, this is the access list number. Then I'll say permit IP from the host 10.1.1.1 to the host 10.1.1.2. This is done. Then we will create VLAN access map. We will say VLAN access map. Then we have to give a name. So let's say this is VACL. So I'm giving the name as VACL and a sequence number. Let's say 10. Match IP address and ACL number is 100. Done. Then action I have to give. So what is the action I want to take here? Drop. This is clear. Then I will use the same command again, but here the sequence number should be higher. That means other than this traffic, the rest of everything I want to permit. Done. I have created the access list. I have defined the action. Next thing I need to do is VLAN filter. Then what is the name of the access map? VSA, right? Then after what I have to give? VLAN list. And in which VLAN I want to filter? Right now by default VLAN 1. Now let's see if the communication is going on. What happened? Within the VLAN, the communication stopped. And you will see if I'll say no here, if I'll remove this command. Okay. I have the communication. This is my VLAN access list in action. Again, if I'll give the command, you will see again request timeout. Clear? Online people clear?
Sir, why did you use VACL 20?
This is to allow rest of the traffic. Like this is the traffic I want to block, right? So for this traffic, I have defined an action. But remaining traffic, remaining all other hosts in my VLAN, they should communicate, right? So for them, I have used this. And when I don't define any IP address or action, by default, everybody and allow. Is that clear?
Okay.
Yeah. Because if I will not use this, then what will happen? Remember, implicit deny statement that denies all the traffic other than whatever you have configured. So to bypass the implicit deny, I have used this VACL 20 now. Yes.
Okay.
Yeah. All right. So this is your VACO. Next thing is about FHRP. VACL notes. And then start notes. Okay. So VACL is clear. Next concept is about FHRP. Yes, you can define the protocol. I have defined all the IP protocols right now. If you check my while selecting the traffic, right? You see in my ACL, I have said what? Permit IP host. You can say permit TCP, ICMP, whatever the protocol you want to build up. And this is specific traffic only from this host to this host. This is specific traffic only because extended access list, right? You can block a specific service or host. Okay. Okay. So this is FHRP stands for what? First hop redundancy protocol. First hop redundancy protocol. Why this protocol is used? To provide gateway level redundancy. It is used to provide what? Gateway level redundancy. That means if one of your gateway fails, still you have the second gateway. Okay. So you can say FHRP is used to provide gateway level redundancy. Now, if we talk about FHRP, so under FHRP, we have three protocols. Okay. FHRP has three protocols. Number one, HSRP. Number two, VRRP. Number three, GLBP. Okay. So these are the three protocols. If we talk about HSRP first of all, so HSRP is the one which is Cisco proprietary. This is the one which is Cisco proprietary. So first let's talk about HSRP. Hot standby router protocol. Now this protocol, this is what? Cisco proprietary. And this is a Cisco proprietary. Okay. Here, two or more routers or L3 switches. Okay. Are configured with the virtual IP address. Okay. Out of these routers, or switches. One is elected as active and the other one is elected as standby. Okay, and remaining are candidate. Okay, now if the active router goes down, the standby will take over the duties of active. That means basically the standby will become the active and you will start forwarding the traffic. Start forwarding the traffic. This is clear. If we talk about HSRP, so the standby router keeps track of the active one, okay, by sending hello messages. And if we talk about default hello time is 3 seconds. And if we talk about default hold time, that means how long it will wait before considering the active as down, it will wait for 10 seconds. Okay. Then how the active router is elected? Active router election criteria. So number one, highest priority is checked. First of all, highest priority will be checked. Router with the highest priority will become active. And if we talk about the default priority, default is 100. And if priority is a tie, in that case, highest IP address will be taken as a active. Okay. And we can configure a max of 16 HSRP groups. Another. Clear? When it comes to HSRP configuration, if we talk about HSRP configuration, so the configuration is also simple. Whatever the client side interface is there, you say interface name, then you say standby, group number, IP, and the virtual IP address. Okay. Then there are few optional things that you can configure. Although your HSRP configuration can be done from here itself, that is it. But if you want, let's say you want a particular router to be active, so you can configure the priority also. So here you can configure the priority value, which is between 1 to 254. Okay. If you configure priority to 0, that router will not take part in HSRP. Then you can also configure something called as preempt. Okay, so according to preempt, what happens that your high priority router is always active. What is the preempt feature? That high priority router is always active. And in case of HSRP, the preemption is by default disabled. Preemption is not enabled by default. This is clear. And preemption you configure only on high priority router. This command you configure only on high priority router. Okay, so if I mention this thing here, that this command, first of all, preemption means high priority router will always be active. Second thing, preemption is configured only on high priority router. In HSRP, preemption is by default disabled. The preemption is disabled by default. This is clear. Okay. So this is your
Yes,
yes.
command for checking which one is primary, which one is standby.
Show standby. For troubleshooting, the command is show standby. Okay.
Okay.
This is clear. Now, if we talk about topology, so as of now, you can see this is our topology. This is the topology. So here I will be using these two L3 switches to configure the HSRP. I'll use this L3 switches to configure the HSRP. Okay. And what we'll do is in this part here, in this part, we'll configure AHRP, dynamic routing. AS number 100. This is clear because that is the internet side. So this is my edge router, and beyond that, I have the internet. So here in my organization, I'm running what? Dynamic routing. Clear? Okay.
Sir, EAGRP is 90, right?
AS number I'm telling, not the administrative distance.
Okay.
Okay. So this is the lab we will be designing, and this is the virtual IP address that we will be configuring. Clear? Okay, so let's go to the lab. I have already started all these routers and now. So first of all, these VPCs we will configure with the IPs. So let me take access of the devices. Which one? HSRP. It's a separate protocol itself. Okay. So this is L3 protocol, you can say. Because it's not using a TCP UDP. This is a L3. So the R1 access I have taken, switch 2 and switch 3. Okay. Then also I need to take access of these PCs. PC5, PC6. And on this switch, I'll enable port fast so that I don't have to wait for 50 seconds. First of all, on the switch, I'll configure port fast so that you don't have to wait. Enable. Configure terminal. Interface range 0 by 0 to 3. Spanning tree port fast. Okay, I have enabled port fast. Other than this, I don't need any configuration on the switch, so I can close it. Okay, then these routers, I'll see. These are the switches. Now see, this router configuration, R1 configuration. Okay, so let's say this is R1. Host name is R1. Z0 by 0, 11.1.1.10. And this is 12.1.1.10. So here the configuration is done. Then I'll configure EAGRP here. Router EAGRP 100. Then I'll say network 11.1.1.0. And I'll say network 12.1.1.0. And I'll say network 8.8.8.0. Because I have a loopback also, right? Interface loopback 1. I'll clear this 8.8.8.8. This is clear R1 configuration. Yes or no? Clear, right? Okay. Now switch to configuration. Now this is a switch. So on this switch, first of all, interface gig 0/0 configured with the IP address. One dot one. Correct. This is configured with the IP address 1.1. But since this is a switch, it will not accept an IP address on the interface. So we have to do what? We have to say no switch port to disable the L2 characteristic and enable L3 on the switches port, right? This is clear. Similar I have to do with another interface. Z0 by 1. This is about the 11.1.1.1. Correct? Okay. Then here also I have to enable EAGRP. So to configure EAGRP, first of all, I need to enable what? IP routing. On the switch, I have to enable IP routing. Then I'll say router EAGRP 100. And I'll say network 192.168.1.0, 255.255, 255, 0. Yeah. Okay. Then I'll say network 11.1.1.0. This is clear. This is the configuration done. And here we don't require default gateway. Now this is switch 3. This is 3. And this is 3. And this one is 2. So on the switch 3, what are the IP addresses we have configured? On the Z0 by 0, we have 1.2. Z0 by 1, we have 12.1.1.2. So here we have 12.1.1.0. This is all the configuration, correct? Any doubt in the configuration? Okay. So R1 configuration, copy. This is R1. This is switch 2. This is switch 3. This is clear.
Sir,
Now-
by default, L3 switches are also in L2 characteristics, right?
Yes.
We need to manually do the
Yes.
IP accounting. Then only it will start L3, right?
Yes.
Okay, thank you.
Okay. Now see here. For these two PCs, I have two gateways, 1.1 also, 1.2 also. At a time, I can configure either this or this. But what will happen? Any one of them, if I will configure and if that goes down, I don't have any communication now. Right? Problem everybody understands, right? What is the problem? Why we have the HSRP protocol? Because we want redundancy that if my gateway fails, I should still have a communication. So to have a redundancy, I have used one more layer 3 switch. Correct? So now what? I have two switches, but with two switches, I got two different gateways. So that means if these guys are using the first gateway and if this goes down, they will lose the communication. Then I'll have to go and change the gateway here. Again, I'll change the gateway to this one. So they will start forwarding like this. But what if this goes down then? Again, I have to change. So if there are one or two PC, you can go and change the gateway, totally fine. But if we are working in an MNC, thousands of systems are there, not possible, right? Not possible to change the gateway. So we come up with the HSRP protocol. Is that clear? Cisco came up with the HSRP protocol. So now what we'll do, we'll configure the HSRP, and according to HSRP, the virtual IP that we are going to configure is 1.254. Okay, so on which interface I'll configure? Z0 by 0. So let's go and configure it. So switch to interface gig 0/0. Then we will say standby, and you can see how many groups you can configure. Now here you can configure 255 groups. Okay. In packet tracer, the router you have, there you can configure only 16 groups. This is clear? Okay. So I'll say standby 1. Then I'll say IP and the IP that I want to configure, which is 192.168.1.254. Done. Same thing I'll configure here also. Interface gig 0/0. Power is on. See. I guess backup is also done. Server also post the connection. Now server will come up in 15 minutes. So we will see the practical tomorrow. Okay. All the comments I have shown you, topology I have shown you, so you guys can refer to it. Okay, because 15 to 20 minutes server will take to come up.
Sir, the
Okay,
last three lines are pending in the note. Can you please show me the note?
please let me share the screen. In the configuration, this one.
I take the snap, sir. This is fine.
Done.
Yes, done.
Done, right?
Sir, yes, sir, done. I take the snap. That is fine. Thank you.
So also you will find this again, this paint file in the right. Okay.
Okay, sir. Okay, thank you.
Okay, guys, then I'll see you tomorrow. Because server again 15 to 20 minutes it will take to come up. So
Sir, one question between these two router or L3 switches, right? Is there any communication connection between these two to check the heartbeat like that?
yes, hello is there, right?
Okay.
They will exchange hello messages.
Okay.
Okay, you see here, I said every 3 seconds.
Direct physical connection is not there, na? Between these two.
Not there.
Okay. Thank you.
Okay. All right, guys, then see you tomorrow. Have a good day.
Thank you, sir. Bye-bye.
Thank you, sir.
Okay, guys. Bye.